Good afternoon, everybody. Welcome to a snowy but fun-filled afternoon of Chem 170 with your host, me, Dr. White. How you doing? Who's ever dreaming of a white Christmas? Stop. We already had it. I like snow, except when I have to get it off my driveway, which after class today, I will go out and do that. I'm going to spend some quality time with my snowblower this afternoon later. All right, let's get to work. I had promised, so I better do it now, but I will cut it out of the video, but I'll post it as a private video on my YouTube, which I'll send out a link. And that is what I call the method. With that, let's get to work. All right. Any of you happen to think of alkanes when you drove by a gas station? All right, I got to work on this group. Remember, organic chemistry is all around you. I stole that from SpongeBob, and it won't hurt for you to think about that. All right. You should be learning, if you haven't, this table. You should know all the alkyl groups. You should know a methyl group is CH3 just as well as you know your first name. You should know an N-butyl group is this, as well as you know your first name. These are all available in Blackboard in the lecture section in the file labeled key alkyl groups. And you should know these. How do you memorize this? You write it down and say it 5 times. Isopropyl, you write CH3, CH3 line, and write the word isopropyl. And you say it out loud. And also, if you're in a library, you can say it silently in your brain, but verbalize it without saying it. Do that 5 times, and a little later, do it again a couple of times. This will be burned into your brain. If you don't know this chart, you just lost 50 points out of 100 on test 1. All right, next, the alkanes. You should know this chart like you know your first name. What do you need to know? Pentane, 5 carbons. Heptane, 7 carbons. Nonane, 9 carbons, 1 through 10. Now, the alkane names for straight chain alkanes goes up to thousands. Guess what? You're never going to encounter that, and I rarely use it. Later in the semester, I'll talk about 11 and 12. When we get to higher numbers, I'll teach you about common names. And I'll teach you then the common names that have longer chains. Even those are not that many. But again, by next Monday, you should know this, because test number 1 is eventually coming up, and you're not going to learn organic chemistry the day or 2 before a test. All right. On Monday, and I'll just do a quick little review, we were talking about alkane and cycloalkane nomenclature. And let's go through a couple. And the question is, what's the IUPAC name? And IUPAC for my class means the official name. I'll never ask that, what does IUPAC stand for? Even though I think it's cool to say International Union of Pure Applied Chemistry, I'll never ask that on test. But this I can. So the question is, now why don't you try that out now on your own? What's the IUPAC name for that? Remember, you have to find the longest chain, name that, and then name the alkyl groups on there. And if we're in face-to-face, which I can't do easily on Zoom, I would have on the board, I'd write, or I'd show the slides, and I'd write this on the whiteboard, the IUPAC names and the alkyl group names. And I'd recommend for next couple of classes, you print that out or write it out so it's in front of you when I ask questions like this. All right, I think everybody's done. Let's do this. First, you have to find the longest chain. That's one chain, 5. Another one would be 1, 2, 3, 4. Another one would be 1, 2, 3, 4. And based on that, the longest chain is 5. And the IUPAC name for an alkane with 5 carbons is pentane. So the root name, base name, is pentane. As soon as I say that, that's all spoken for. And I have an alkyl group left over. Oh, it's your old friend, the methyl group. And now you have to determine what carbon it is on, and you give the IUPAC number in such a way, and the IUPAC rules, that the alkyl groups get the lowest number. And you can only start from an end. And notice if I start from this end or this end, they're both on carbon 3. So that'd be 3-methylpentane. And let's do one more. And while you're doing that, let me remind you, tonight from 6 to 7:15, I'll have my office hour. Now, one of the things I was thinking about earlier today, can each of you, well, maybe I can do it right now after we do this. one thing I neglect to mention, if you have taken organic chemistry before and not done well, which is why you're taking it again, one, I've had students do quite well. And two, if you need extra help or any help, contact me. I'm here to help you. And don't forget, it's still always going to be true. There's no such thing as a dumb question in my class. All right, let's do this. Oh, we've got a ring. And how many bends in a ring? How many carbons? Good news, when I give a test, I have software. It's called ChemDraw that I've been using for many years. It's best out there and all other organic chemists. And my rings will look a lot nicer. All right, so 6 carbons is hexane. It's a ring, cyclohexane. Student on test 1, common mistake, students forget to put the cyclo, and I mark it wrong. Now, what do we have left? This is an ethyl group. This is an isopropyl group. I'll show you the IUPAC, but there are 3 other answers I'd accept. E comes before P. Remember, the prefix you ignore for alphabetical priority. Therefore, it would be ethyl, isopropyl, cyclohexane. Now, the ethyl group, since it says alphabetical priority, that was word out, should be on 1, and the isopropyl will be 3. Now, if you'd put 3 isopropyl, 1 ethyl cyclohexane, I would give you full credit. If you put 3 ethyl, 1 isopropyl, I would give you full credit. But the way I always will do it, in my answer keys, I will do the IUPAC name following their rules, because I expect myself to do that. All right, let's do one more problem. You know something, let me just do something. And why don't I try this? Draw 4 ethyl decane. And sometimes I'll say, draw the condensed structure for the following. That means you don't have to show carbon, hydrogen, single bonds. You use the condensed like I always do, like CH3. You're doing organic chemistry, and hopefully it's not that painful. And don't forget your friend, there's always 4 bonds to carbon. I think everybody's done, so I better get to work. How do you decode this to know what you draw? You start from the right, move left. And decane is 10 carbons, straight chain. Then ethyl group is CH3, CH2, and it's on carbon 4. Now you can start counting from the right or left. Most of you are going to do it this way. And on carbon 4, there's an ethyl group. You can put the carbon on that side, this one, doesn't matter. You can even have it going down, even though chemists usually don't do that. And now I have to put in my hydrogens. Remember, it's now your solemn responsibility, being a member of my class, to tell me if I make a mistake doing anything, but especially putting in hydrogens. And that's how you do it. 4 ethyl decane. Let's do one more. And good news, when I do tests, they'll be typed. And draw the structure for tert-butyl cyclopentane. 3 points each. Yeah, it looks like everybody's done, so I better get to work. How do you decode this? You start from the right, move left. Pentane, 5 carbons, but the cyclo tells me I have a ring. You'll probably get tired hearing me say that, but when I say a cyclopentane ring, I think of little green houses in Monopoly. And then we have a tert-butyl group, and since it's only one alkyl group on the ring, I can put it on any carbon. Most of you are going to do this. And I'm done. And that's how you do it. Now, like I said, this is not the most exciting stuff, but it's how we communicate. And it's important to have a strong foundation of nomenclature, how to name things. Now, let me do something right now and go to gallery view. I have a question to ask all of you, and that is, give me a thumbs up if you wanted to, you would be able to come to my office hour on Tuesday or Wednesday from 6 to 7:15. Give me a thumbs up. You can use your emoji, or you can do it on your screen if your video's up. All right, how many of you cannot come to my office hour because you're working or whatever? Give me a thumbs up. All right, I see 1.5. See, I told you I'm a good problem solver. All right, if you have a better suggestion when I should have it, in the mornings on Monday, Tuesday, and Wednesday, I teach, or I will be teaching, and we'll start in a couple weeks, the class I'm teaching at another school starts later, let me know and I can move it. Or if you can't, and if you really need help, let me know and I'll set up a special session if you need extra help. I can set up a Zoom meeting, I can meet you. All right, let's get back to work. And wrong folder. So switch is off, but sometimes on entrance exams, they'll ask the question about physical properties and switch. This will never be on a test of mine or final, but boiling points. As you have more carbons in an alkane, the boiling point increases, heavier molecular weight. Now, when the chain has more branches, the boiling point goes down. Straight chain, more carbons, higher boiling point. And same thing, when you have more branching, you have 8 carbons, the one with more branching will be lower boiling point than the one without. Now, there's something a switch click is still off called conformations. And conformations, also known as conformers, are stereoisomers, which atoms are connected together in the same order, but are arranged differently in space. Again, switches off. It reminds myself I should do this. Switches off, but here's a model of propane. Each center is carbon and the spokes are hydrogens. Now, if you look straight down here, you can see I can rotate around that carbon-carbon single bond. And one of the things Mother Nature doesn't like, meaning it's high energy, is crowding. We actually have a name for that called steric hindrance. And notice here, this hydrogen is close to this methyl group. And if I have another conformation, it's farther apart, it's close again, it's the farthest. And each one of these conformations has different energies. And this for a 2-semester for organic chemistry or chemistry majors, we'd be talking in depth about it. Unfortunately, I don't have that time. There are other things more important. All right, now a major part of this course, you'll be learning various reactions of different functional groups. And these are called general reactions. And the functional groups react the same way. And the first one I like to teach you is if you have an alkane plus oxygen called combustion, you get CO2, water, and heat. Now, let's take a look at this on my whiteboard. And I'll expand it. I should have also had cycloalkane. And that's general reaction because heat is not considered a chemical product. And on a test, I'll have this following. Three points each, give the product or products, have it in a bracket. Now, let me just remind you something in case you forgot. Chemical reaction, A and B. I'll never ask this on a test, are the reactants. By having worked most of my life in the chemical industry, you'll hear me more likely call them the starting materials. And they're at the base of the arrow. At the head of the arrow always are the product or products. And again, I'll never ask that, but I'll use this terminology, starting materials and product. So the question is, how do you figure out what are the products here? Well, in organic chemistry, you identify your reactants, starting materials. What's this? It's propane. It's an alkane. It could have been a cycloalkane. It's not. And this is oxygen, one of the other reactants. And I've learned this general reaction. Alkane or cycloalkane plus oxygen gives me CO2 plus water. Whatever it is, that's always going to happen. And that's the beauty and that's the strength of general reactions in organic chemistry. And here, therefore, propane, oxygen, since an alkane, will give me CO2 plus water. And good news, in organic chemistry, unless you have to figure out charge weights, how much of each chemical you need to weigh out to react, we never balance a chemical equation, which means in my class, you'll never have to balance a chemical equation. And I'm done. And the answer is carbon dioxide and water. If I look at the time, it's time for a break. So let's take a 5-minute break. I'm going to get up and stretch, and I'll see you in 5. Time to get going. All right. Now, I was just starting to show you general reactions. And the general reaction I just showed you was combustion. And the general reaction is an alkane plus oxygen always reacts together with a spark, which I'm not going to put at our heat source, carbon dioxide and water. And propane reacts with oxygen to give CO2 and water. Now, in this class, I'm not going to sugarcoat it. There's memorization. And you need to memorize this general reaction and other ones I'll be giving you this semester. A number of years ago, I don't know if the count was correct, one of the students said the end of the semester, near the end, that I had taught them, I think it was 52 general reactions that they had to memorize. And this is something you need to learn to do the problems. And these are the building blocks, the tools organic chemists like myself use to make molecules that are in your daily life. Now, how do you memorize this? You write down alkane or cycloalkane plus oxygen, CO2 and water, and say it out loud. And do that 5 times. And that will burn it into your brain. Do it another time, and it works better than flashcards for most students and for me too. Now, as I told the first day, I'm pretty sure I did, I had 2 students after test one got an A, the other didn't do good at all, really didn't do good. And the one who didn't do good asked me, Dr. White, what can I do to do better? And I said, did you write the general reactions down and say them 5 times? And she said, that's a lot of work. And her friend, who got a very good A on the test, turned to her and said, yeah, but I got an A. It works. And her friend, who didn't get a good grade, got the message, did better, much better on the next test, and did that. All right, your turn. Give the organic product or products for the following reaction. And that's 4 carbons, that's butane. In a chemical reaction, I'll never ask you to name the compound, but I thought I would, because that's the stuff in the liquid and the lighters that you react with oxygen. I think everybody's done. So how do you determine what are the product or products for this reaction? And the answer is you look at this and say, oh, that's an alkane. It could have been, and I'm reacting with oxygen, so I know that could have been a cycloalkane. And when I react it with oxygen, I get, because I've learned this general reaction, hint, you've learned that, I get CO2 plus water. Those are my products. Therefore, pentane reacting with oxygen will give me CO2 plus water. And you don't have to balance it ever in my class. And that's how you do it. Now, everybody have this down that want to write it down? Now, I'm going to tell you a secret. A general thing that chemistry instructors, organic chemistry instructors do on a test is the following. They put in a problem, a big, scary molecule. And if students don't know how to identify what they're dealing with, they go eek. Well, I don't know if they go eek, but they freak out. And the question would be, what's the organic product or products are the following? And if you look at this, if you don't know, well, wait, that's only carbon, hydrogen, and carbon-carbon single bonds. That's an alkane. And it's reacting with oxygen. I know this could have been a cycloalkane. And that gives me always carbon dioxide and water. And therefore, even though this may look like a big, scary molecule, it's not. It's just an alkane. And therefore, I know I'll only get carbon dioxide and water. And that's how you do it. Now, that's the chemistry instructors, organic chemistry instructors trick on a test, put a big, scary molecule. It's big and scary if you don't know how to identify it. You do, it's not. And I will be inoculating you, oh, that's a fancy word, against that big, scary molecule trick by teaching this. But if you don't learn it, it's going to be big, scary, and you're going to get it wrong. So don't. You need to learn these general reactions. The first one is alkane or cycloalkane plus oxygen gives carbon dioxide, CO2 plus water. Now, interesting sidelight. Have you ever been in the dead of winter behind a car and you see, say you're at a stoplight or stop sign, you see this liquid coming out of its tailpipe. And you say, oh no, it's leaking gasoline, it's gonna blow up. Nope, nope, nope. Actually, I was in a car with a friend and they thought that. I said, no, no. When a car just starts out, its whole muffler and tailpipe area is very cold. And in your car engine, the gasoline is burned, combustion, to make carbon dioxide and water. Now, when the tailpipe and muffler are cold, what normally the water that comes out of the tailpipe is a gas, a vapor. But when it's cold, it condenses into the liquid, and that's what you're seeing coming out of the tailpipe. Now, one of the things I like to do this semester, because A, I'm an organic chemist who worked in the chemical industry, I know these things, and B, I'm an organic chemist who has lived in the real world and knows these things, is to teach you about where you find things and how things are used, organic chemicals, in the real world. And I also ask questions like that on my test. So let's look at an example. Where are alkanes? I don't have a slide. One year I'll make one up. Alkanes in our life. Well, methane, you know as natural gas. CH4. And that you use for cooking, heating your house, apartment, or condo. Also, your hot water heater is used for that. Now, you know propane, and these are things you should know, is used for your barbecue if you have a propane barbecue. Oh, I'll be subtle. you should know at least one of these. If I were to ask on a test, give an example of an alkane in your daily life, well, you could put down propane, barbecue, methane, natural gas. Gasoline has alkanes in it, like octane. So gasoline contains octanes. Another one, which contains longer chain alkanes, is baby oil. And a number of years ago, I had in my class a nurse who was needed to take organic chemistry again because she was going for a master's degree in nursing. And she had been a neonatal and natal nurse. And as soon as I said baby oil, she raised her hand. I said, yes. She said, well, we tell new parents, be careful of baby oil. It's combustible. It will burn. Don't use it around candles or cigarettes. Back then, they were still smoking. Who would smoke around a baby? I don't know, but still. Now, another one that's also alkanes, but longer chain. I used the trade name Vaseline, also known as petroleum jelly. And this is flammable. And one of the things, I don't know if I call it a hobby or just something, especially since the pandemic hit, what's called a prepper. If there's an emergency, I want to be prepared for it. And one of the things preppers are always prepared for, you have to bug out and leave where you're living and go out away. How do you stay alive? And one of the things is to be able to make fire. And to help make fire, an old prepper trick is take cotton balls and rub them with Vaseline, put them in a Ziploc baggie, and they'll help you make a fire with wood. Why? Because the Vaseline is flammable. It's an alkane. Now, if you get the very, very long alkanes, paraffin wax, which is not truly a wax, but it's called a wax, is alkanes, very long chain alkanes, and it's 50% of the weight of candles, high quality candles. And later in the semester, I'll talk about one company I worked for, got its start in the Netherlands back in about the early 1800s, taking certain chemicals and making the other 50% of the chemical for candles, and then they made candles. And that's in the Netherlands, which I work for. So you should know at least one of these. That what's an example? I can ask, what's an example of an alkane in your daily life? And that could be methane, natural gas, propane, gasoline, baby oil, Vaseline, or candles, paraffin wax. All right, good news. We finished our first chapter. And what does that mean? On Monday, I will go through the alkanes practice problems. Those are located in a folder in G2L called practice problems. I also have another folder called practice problem answers. I highly recommend you try the problems, some of them, before you look at the answers. How do I go through practice problems in class? Do I go through every one? No, but I'll go through key ones, and I'll also go through problems any of you ask me to do. So we'll do that on Monday. Now, I should mention that students who do the practice problems do well in my class. I'll say that again in slow motion. Students who do well in my class do the practice problems. And when we go through that on Monday, I'll show you how, if you want to do more, I can show you how you can do your own. And come to my office hour after class, and I can see if they're right or not. All right. Guess what time it is? It's new chapter time. New stuff. We're getting into some good stuff now. And what's that new chapter? It's the alkanes and alkynes. Alkenes and alkynes. This is chapter 3. The slides you're seeing on the screen are available in D2L, cleverly labeled chapter 3, alkenes, alkynes. Now, what are alkenes? An alkene is a hydrocarbon that contains a carbon-carbon double bond. We show that by 2 lines. That's a double bond. And this is an alkene. Now, there's other stuff bonded to it, and we'll talk more about that in a little while. And that's an alkene. Now, a double bond, I'll mention it again. Each bond of the double bond has 2 electrons, so that's 4 electrons. And you should know that. Now, that's an alkene, it's a double bond. Now, this is the formula, and you don't have to know that. But on some entrance exams, they say if you have a double bond with 5 carbons, how many hydrogens do you have? Well, N is 5, 2N is 10 hydrogens. I think it's one of the stupidest questions you can ask in organic chemistry, so I don't ever ask it. But you should know an alkene is a carbon-carbon double bond. And they're molecules, and they're hydrocarbons, which means there's only carbon and hydrogen atoms. Now, alkynes, notice ENE ending alkene. Endings are important in organic chemistry. Alkynes, or YNE, alkyne, are hydrocarbons, molecules with only carbon and hydrogen, that contain a carbon-carbon triple bond. And triple bond are 3 bonds between 2 carbons. And this is an alkyne, a general. And each line is 2 electrons. So 3 times 2 is 6 electrons. And you should know an alkyne, YNE ending, triple bond, alkene, ENE ending, double bond. So we're going to talk about molecules, hydrocarbons with double bonds and triple bonds. And the formula, which I'll never ask for an alkyne, is CnH2n minus 2. That will never be on a test of mine. It'll never be on the final. And you've got it on video now. Speaking about video, because after class, I'm going to end class a little earlier, and I'll talk about that in a second when I do, but we got a while. I'm going to go out and do my driveway, so it might be a little later today or early tomorrow morning before I post today's video on my YouTube channel, but it will get there by tomorrow, 10 a.m., if not a lot sooner. All right. One of the nice things about what I just said earlier that I know about organic chemistry in our life is a question you should be always asking yourself, why am I learning this? Well, the obvious answer is, well, you want to get a good grade because somebody told you had to take this, like to get into nursing school or other programs or other schools. But why really learn this? Good question. You should always ask that question, and I will, and I'll answer it too. Let's look at alkenes. As soon as I find where did I hide, there we go. And if we're going to talk about alkenes, let's talk about carrots. Now, an interesting molecule is called beta carotene. And here's the structure of beta carotene. Now, as everybody see, each bend of the line is a carbon, each end of the line is a carbon. Do not write this down. Do not write this down. But between these two carbons here and here, there's two lines, that's a double bond. Over here, there's a double bond. There are a lot of double bonds. I think I counted one time 11 of these. Now, this is beta carotene. You're probably saying, why am I learning this? Well, it turns out this is the molecule that makes carrots the color they are. It absorbs all the light except the colors of the rainbow. Remember RGB in high school? Red, green, blue, whatever, so on. And it's orange. Have you seen on your screen here, you see some Mr. Carrot, no, carrots. And they're that color because of that organic molecule, beta carotene. That's an alkene, actually polyalkene, poly. Now, another similar, and again, don't write this down, alkene, carbon-carbon molecule with double bonds. This is called lycopene. If you notice, it's got a double bond here, one there, two there. Lots of them. Remember, every bend in the line is a carbon, every end of the line, these are methyl groups. I don't do this in my class. For this class, because students have trouble, it's easier when I just show carbohydrates, and I want you to learn it. So that's why I make it easier. Now, you say, all right, lycopene. Where do I find this? And lycopene is this solid. And notice the color, red. Lycopene is the molecule in tomatoes that cause tomatoes to be red. And you can see a nice ripe tomatoes on your screen. The red color is due to an alkene, polyalkene molecule with a lot of double bonds. So is this important? Oh, let's do one more. Everybody see the structure on your screen, the ring with a double bond, and then right here you have a double bond outside the ring. This is called limonene. And this is the molecule that's responsible for that citrus smell and things like grapefruits and lemons and limes and things like that. How many of you ever seen a product, cleaning product, where they say, it's got that lemony fresh smell to it? And you say, oh, yeah, it smells good. It's going to make my stuff real clean and smell good in my house. Well, what you're really smelling is this molecule. By the way, it does help clean too. And it has two double bonds. So the question is, why are you learning about double bonds? Well, they're in carrots, they're in tomatoes, they're in your cleaning products, they're in your citrus fruits, and some of the other, like limes. I guess that's a citrus fruit. I don't know. But anyways, it's everywhere. Remember, I said organic chemistry is all around you. I stole that from SpongeBob. So we have an alkene, carbon-carbon double bond. Alkyne, carbon-carbon triple bond. Now, next slide switches totally off, but I thought I'd mention this. Unsaturated hydrocarbons, alkenes, alkynes, double bonds, triple bonds. They're called unsaturated because they are hydrocarbons that contain less hydrogen atoms than the alkenes. In other words, you can't put any more hydrogens into an alkane, but unsaturated, because an alkane is full, saturated. But unsaturated, you can add hydrogens and that will convert them into alkanes. I'll teach you that later on. And they're hydrocarbons that contain one or more carbon-carbon double or triple bond. And I'll teach you later on that, the addition of hydrogen, that's H2, hydrogen gas, will convert alkenes to alkyne and alkyne into an alkane. And in industry, I have work that's called hydrogenation. In chemical plants I've managed, in research labs, I've run the reaction to do hydrogenations of alkenes. I've never done an alkyne. All right, skip this slide. I forgot to pull it. All right, now the coming chapters, this one and a number of them, I'm going to be doing the same thing. I'm going to introduce you to the new functional group. The functional groups are a combination of atoms, and I'll never ask on a test, what's a functional group? And they always have similar nomenclature and they react the same way. Just like, you look over here, I have a door that allows me to go from this room to another room, from one place to another in a building. If you go to my front door, it won't look like this, but it's still a door and I know what the function is. And if you go in your house, or if you go to a car, you know, if you open the door, it allows you to go from one area to the other inside the car. Well, organic molecules are the same way. And first I'll introduce you to them, like here's a double bond, here's a triple bond. I'll talk about some either beginning or late after nomenclature, some where do you find it in our daily life. Boy, talking about alkenes and alkynes is thirsty work. But anyways, and then I'll go through the nomenclature. And this one I won't, but later chapters, how do you make that functional group? And then the fun part, how do you react it to make things? And the things we'll make, I'll teach you what are they used for in our daily life. And that's my training and my experience in the chemical industry. I'm a synthetic organic chemist, meaning synthesis, fancy word to make. And my experience is, how do I make molecules that other companies buy from the company I work for products that you buy? And we'll learn about it. Things like soaps, cosmetics, fabric softener, and a whole lot of other things you probably never thought about. All right, let's talk about alkenes. The ending ene is used to designate a double bond. Now, don't worry about when more than one is. I should have taken that out. We'll come back to a triple bond in a little while. So how do you name it? Well, let's put a molecule on the whiteboard. All right, here's the molecule, and the question would be 3 points. And how do you name this? Now, listen carefully. From this day on, when you look at an organic molecule, you should look for what's different. What's not a carbon-carbon single bond, what's not a carbon or hydrogen atom should get your attention like this. Hopefully I got your attention, or like that. If we look here, what's different? I have a double bond. 2 lines is a double bond. And that got my attention like the lights and bells at a railroad crossing, which tells you stop, train's coming, double bond. So as soon as I see that, how do you name that? You find the longest chain, and this is important, that has both carbons at a double bond. In this case, there's only one chain, 1, 2, 3, 4, 5. Now, the rules are name that as an alkane. Now, don't write this down yet, you'll see why. Now, because we have a double bond, we'll drop the ane ending from the alkane name of the longest chain. So I've dropped that. And for double bond, the ending is ene, pentene. Ene ending tells me I have a double bond. Next, you have to locate what is the lead carbon, the carbon closest to the end of the chain with the double bond. In this case, is this one, it's on carbon 1. So the IUPAC name for that is 1-pentene. So look at the molecule, look for what's different. What's not a carbon-carbon single bond, carbon or hydrogen atom, should get your attention like that. In this case, we have 2 lines between 2 carbons, double bond. Find the longest chain with both carbons in double bond, name it as an alkane, which is why you need to learn that alkane table. Pentane, drop the ane ending, double bond ending is ene. So that becomes pentene. And then the lead carbon of the double bond, you number in such a way that it's the lowest number in that chain. Now, if there are any other alkyl groups, you number them and name them like you've done for alkanes. So that's how you do it. Before we do B, let's look at A again. Something I neglected to mention. How many bonds to carbon are there? 4. Let's look at this carbon. How many bonds are there? Each double bond counts as 2 bonds. So there are 2 bonds here to this carbon, and 4 minus 2 is 2 hydrogens. If we look at this carbon, again, double bond, 2 bonds. And this line tells you there's another one, so 3. There's 4 bonds to carbon. 4 minus 3 is 1. So that's why on that carbon, there's only 1 hydrogen. Remember, a double bond counts as 2 bonds to that carbon. All right, why don't you try B? Give the IUPAC name for the following carbon or carbon following molecule. I normally have a table on 7-heptane. All right, looks like everybody's done. So I better get to work. If I look at this molecule, I'm going to look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Ooh, a double bond. And that got my attention like that. And now I know I have to find the longest chain with both carbons of a double bond. Be across 7, or I can go down to here, that would be 7. 7 is heptane. Drop the ane ending, double bond, ene ending, heptene. Next, what carbon of both carbons of the double bond are the lowest number closest to the end? And the answer is 1. Am I done? Well, as soon as I say 1 heptene, that's spoken. Oh, look, something's left over. It's your old friend, the methyl group. CH3 is methyl. What carbon is it on? Carbon 6. So this would be 6-methyl, 1-heptene. Let's go through that again. Identify the double bond. Look for what's different. What's not carbon, what's not hydrogen. Should get your attention, or it's carbon-carbon single bond. Get your attention like that. I'll be very honest. When I look at any structure of an organic molecule, that's the first thing I do immediately. What's different? Because that's where you'll learn later on all the action and fun is. That's where all the fun happens. And we have a double bond. Remember, 2 lines between a carbon is a double bond. And so I have an alkene. How many carbons in the longest chain with both carbons in double bond? 7. Alkane 7 is heptane. Drop the ane ending, put ene, heptene. Next, what carbon of the double bond is close to the end? This case is carbon 1. And then I have an alkyl group, methyl, and it's on carbon 6. And that's how you do it. Now, you'll learn after test number 1, and also if you do the practice problem, hint, remember, I'll go through chapter on alkanes next Monday. The second type of nomenclature question is 1-octene. Draw it. But before we do this, I better mention something. All my tests are multiple part. Never do I use in Chem 170 a multiple choice. I never have, never will. Same thing for my final. Every question on my test and on the final, I'll have covered the concept behind that question. In other words, teach you how to answer it, that type of question at least twice, usually a lot more, but at least twice. I'm not going to throw a question on there that you never saw. How do I do that? That's not fair. I'm not going to throw a question on there. We've never practiced that type of question. That's not fair. Then I might have mentioned it. I teach by my golden rule of teaching, which is I don't do to my students what I didn't like done to me when I was a student. And yes, I was a student a long time ago in a galaxy far, far away. Stole that from Star Wars. Oh, one other thing. If we were face-to-face, I'm going to give you more time online, but face-to-face, my hourly exams, we'd have 55 minutes, then we'd have to go do a lab. And I write my exams. If you've done the practice problems and study, you should be able to be done in 40 minutes. In other words, I don't write an exam that nobody can finish, or only the very top people, which used to be me in math and science when I took high school, college, and grad school. Some of the students couldn't finish. That's not fair, and I don't do it. All right, let's do this. Draw the structure for 1-octene. How do you do that? You start from the end, right, and move left. All of a sudden, I see ene ending. That's a double bond. If that were ane octane, it would have 8 carbons. And the double bond is at carbon 1. Now you can call this carbon 1 or this one. Most of you are going to call this 1. So I have a double bond. Now I know there are 4 bonds to carbon. This carbon has 2 bonds. Remember, double bond is 2. 4 minus 2 is 2. This carbon right here has 3 bonds. Double bond is 2. This is 1. 4 minus 3 equals 1. 1 hydrogen. And the rest you know how to do, so I'll go quicker. And there you go. And that's how you do it. ene ending tells you double bond. If that were ane octane, 8 carbons. So I have my 8 carbons, 2, 4, 6, 8. Oh, did it right. Remember, if I ever do a mistake on the, let me know so I can correct it. And The double bond is between carbon 1 and 2. That's what the 1 tells me. And why don't you try this one? Draw 4-ethyl, 1-nonene. You haven't learned the table on the alkanes. Nonene is 9. On test, I'm not going to help you out with that. You need to know that. Gesundheit. For those who don't, Gesundheit is Yiddish equivalent of when somebody sneezes, you say, God bless. My hearing isn't the best, but my peripheral vision is quite good. If you finish early, please be patient. I try and give everybody time to finish. And I see a message, question. Who thanked me for something, which I don't know, but, oh, I know what. You're welcome. All right, I better get to work. How do you decode this to know what to draw? You start from the right and move left. That's always going to be the case in organic chemical names. ENE ending, that tells me I have a double bond. And if that were ANE, nonane, I have 9 carbons. That would be a 9-carbon alkane. Now, where's double bond start? Carbon 1. So I'll draw my double bond. Therefore, this has to be 2, this is 3, this is 4. I have my ethyl group. You could have put the carbon on that side too. And now I know there are 4 bonds to carbon. Carbon 1 already has 1, 4 minus 2, or actually 2. That means it has 2 hydrogens. Carbon 2 has 3 bonds, 4 minus 3 is 1. And now and this would be the product or the structure. It's a double bond, nonene, 9 carbons. On carbon 1 is my double bond, and carbon 4 is my ethyl group. If I look at the clock, it's time to take a break. Let's take a 5-minute break. It's 2:46 or so by mine. I'll see you in 5 minutes and we'll continue. Time to get going. All right, welcome back. Home stretch. Hang in there. All right, one of the things I should be honest with you about, and that is if we are face to face at ECC, and I've taught Chem 170 many times like that, on Monday, we'd have our normal lecture from 1 until 3:50 with breaks. And when we do it face to face, I take a 10-minute break, 2 of them. Here we only take 5 minutes, so I let you out a little earlier. On Wednesday, I would be lecturing from 1 to 1:50, take a 10-minute break, then we go into the lab from 2 until 3:50. However, the way I'm teaching online, and I'm able to, we're not going to do any actual, unfortunately, manipulation of chemicals at home. It's dangerous and unsafe, but you'll still have the same intellectual experience. Now, if we were face to face at 1:50, we take a break, then we go over in the lab, and today we do check in, and also I'd show you a safety video, which I don't have to because you're not going to be handling chemicals, but I'll still give you the same mental learning experience. So with that, I've been cheating, and today I've gone now, and I'll do for a little while, and we'll end earlier because I have to go do my driveway and other stuff. But normally, in the rest of the semester, we'll get out earlier on Wednesdays because in a lab, the 2 hours, most of that time, you're manipulating stuff. Now, what that also means is during the lab, I get to walk around. I'm not one of those instructors who goes and sits in the front and reads a book or goes on the internet. I spend the time with my students getting to know them, also making sure they're doing the lab right, which is important. However, I can't do that face to face because you're not doing the lab. So what that means is during the semester, I would like to meet with each of you privately on Zoom for about 10, 15 minutes, just so I can get to know you a little. And that's just something I like to do, so you're not just an anonymous name. And that way also in private, if you have any questions for me, you can ask too. All right, let's get back to chemistry. And like I said, we'll end early today, or actually not really, technically early. Now, as I said, I've showed you here, ENE ending double bond, find the longest chain, the double bond, and then number that chain from the end nearest, in this case where it says multiple, we've only done double bonds, and indicate the position of that multiple double bond using the lower number carbon atom of that bond, which I showed you. And don't worry about more than one. And alkyl groups are named the numbers similar to alkanes. Well, we've done that. And we'll do some more practice, but I'd like to move on. Now, there's some common names, and the switch is off for 2 of these. Ethylene is a common name for the simplest alkene. Now, another alkene has a common name, and this you don't have to know, propylene. And you'll learn later on there are molecules made from this, ethylene and propylene, that you use in your daily life. How many of you are familiar with saran wrap or kitchen wrap? That's made from ethylene. And I'll teach you later on when we get into polymers. Now, there's one molecule I do want you to know the structure of, and that's acetylene. And you can write it 2 different ways. This is right justified, this is left justified, hydrogen on the left, carbon on the left. And that's the simplest triple bond. How many of you have ever heard of acetylene torches? You burn acetylene with oxygen, and it gives a much, much hotter flame than methane or even propane. If you ever go and see in the movies where somebody's burning out the lock of a safe with a torch, That's a acetylene torch, and they burn acetylene. Now, when it comes to common names, and for this slide, you just need to know the structure of acetylene. I will never ask you what's the common name of a structure. But I will ask you, here's the common name, and you should know how to draw the structure. So from this slide, you should know, if I ask what's the structure of acetylene, you know it. I won't ever ask ethylene or propylene, but later in the semester, I'll talk about that. Now, switches off for this, and when you have this is called an alkene group, as opposed to alkyl group, two carbons with a double bond attached to a ring or a chain, that's called a vinyl group. This is a vinyl group. How many of you have ever heard of vinyl floors? And they're made with molecules with vinyl groups in it. And that's how they got the name vinyl floors. I will not ask you this ever on a test, but it's something you've learned about in your daily life. So the switch was off for this one. All right, next couple of slides, I'm going to turn, we'll say on a test, to the off position. And when we talk about a double bond, important thing is called the pi bond. And a pi bond is abbreviated by the symbol pi, if you took math. Now, it contains different types of orbitals. An orbital in chemistry, and especially organic chemistry, is the area around an atom that if I could stop all movement, including electrons, that's where you would find it. And there are different types of orbitals. And a pi bond contains 3 sp2. Again, switches off. Don't write this down. Trust me, I'm a chemist. Did that work? How about trust me, I'm an organic chemist and I'm the instructor. But it contains 3 sp2 hybridized and 1 p orbital. Now, this is important, but I'll never ask. The bond angles of a double bond are 120 degrees. And where do I have one? There's no rotation around a double bond. If you notice, here in my model, I have 2 lines. Each one of these is a bond. One of them is a sigma bond. I'll teach you another pi bond. Notice double bond, bond angle, 120 degrees. And unlike a carbon-carbon single bond where you have free rotation around this bond, a double bond is locked in place. And this has some amazing implications in our life, which I'll talk about now in other chapters. So we have this, remember, the switch is off. Now, if we look at a carbon that's in a double bond, the gold are the pi sp2 orbitals. Each one has an electron. If I were to stop time in that sphere of gold where it says that's where you'd find the electron. In the p orbital, above and below, there's an electron zooming around there, in there. If I were to stop time, which I can't, but if I could, in all movement, it would be there. Now, if you have 2 carbons in a double bond, when you bring them together, again, switches off on this slide, and this one too, you form, first of all, overlap, sharing of 2 electrons to form what's called the sigma bond. And then the p orbitals form the second bond, the pi bond. So double bond has a sigma and pi bond. Sigma bonds you can break, you don't break. Pi bonds I can break like that and have fun doing it. And we'll learn about that. And what that means is the pi bond, again, switches off. Will this be on its S? Is trigonal planar. It's flat. If you forget about the electrons, just the atoms, they're all in the same plane. And that has important implications, including why certain fats and oils are healthy and other aren't. Really? Yes. Now, unlike an alkane, the double bond is fixed. It's locked in place. The bond angles, whatever is here is always going to be here. It will never rotate around. And that has important implications. But before I do that, I forgot to tell you, did I ever, I think I might have, but in case I didn't, first of all, it's thirsty work. Did I ever tell you what a great job IUPAC has done? No two different structures ever have the same name. IUPAC has done such a wonderful job, and I mean that sincerely, truly, that any molecule done correctly only has one IUPAC name. Any molecule done correctly only has one IUPAC name. By the way, let's go back and practice a couple more double bond molecules. Let's do it. Oh, let's do 2 for 1. Now, because the double bond is fixed, we show the bond angles, unlike a single bond. Let's call this A. And let's call this B because we don't have a name. If we look at A, even though there's a bend here, this carbon is attached to this carbon, is attached to that carbon, is attached to that carbon. It's got a double bond, the longest chain, 1, 2, 3, 4. Remember, even though there's a bend there, they're still connected together, linked together by the bonds. So longest chain is 4 carbons. There's a double bond. Butane is 4, but you drop the ane ending and put an ene, butene, and the closest carbon to the end, either way you count, it's 2-butene. Remember I told you what a great job IUPAC does and has done? No two different molecules ever have the same name. Now let's look at, and that's a 3 there, compound B. It's got a double bond. And how many carbons are in the longest chain? Even though it looks bent, the bond angles, carbon 1 is bond to carbon 2, bond to carbon 3, and 3 is bond to carbon 4. And that's the longest chain. So that's 4 is butane. Remember, IUPAC, 2 different molecules never have the same name. So that's butane. Drop the ane ending, put ene. Uh-oh. That's 2-butane. Wait a second. Those are different molecules. I even have models of that. Uh-oh. Houston, we have a problem. Here's A. Here's B. These are different. They don't line up. They're different. No matter how I rotate it, they're different. A, B. What's going on? Relax. What this is called is cis-trans isomerism in alkenes. Switches on full time, big time. There, I won't ask you this, but there's no rotation on a carbon-carbon double bond. And we use the term cis for same side of 2 of the same groups or atoms are on the same side of a plane of a double bond. I'm going to show you this. I'll never ask you what cis or trans are, but I'll expect you to know how to use it. And trans means opposite side of two of the same group, and it should also say or atoms on the carbons of a double bond. So cis, same side, trans, opposite side. So let's look at A. If I had a plane here, or if you put down your finger or a pencil, notice this methyl group and this methyl group, or this hydrogen or this hydrogen are on the same side, below or above the line. Now, if we look at B, now the hydrogens or methyls are on opposite side, one below, one above. And we used a prefix cis for same side, trans for opposite. Therefore, A, the IUPAC name is cis-2-butene. For B, trans-2-butene. So now, like I said earlier, and I truly mean it, I have never seen an example where two different molecules that are named correctly have the same IUPAC name. It doesn't happen. They've done such a beautiful job. Which is also why the examples I gave earlier were always one, because I didn't want to talk about cis or trans to butene, cis or trans isomerism. Oh, I've heard that name before. How many of you ever heard trans fats are bad for you, unhealthy? Cis are better. And what they're talking about, and later in the semester, it's an industry I've worked in, fats and oils. Those fats and oils that have a double bond, they do, if hydrogens are on the same side of that double bond, it's healthier for you than when they're opposite. Why that's true, I have no idea. I'm an organic chemist, not a medical doctor. I have some guesses, but they're wild guesses, so I'm not going to even tell you that. But it is true, something medical science has found out. So let's do another example. And the question would be, all right, let's take a look at this. How do you name that? And I'll do this one. You look for the longest chain or look for something different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And I said, ooh, a double bond. And how many carbons are in the longest chain? I don't know. 1, 2, 3, 4, 5, 6. Now this would be 7, but 7, 8. So longest chain is 8. And what do we call an 8-carbon chain? Octane. But it's a double bond. So it's octene. E-N-E ending, octene. What carbon is closest to the end of both carbons of the double bond? If I start from this end, 1, 2, 3, 4, 5, 6. Here, the closest carbon is 3. If I start with blue, it would be 5. So clearly, the closest carbon to the end would be 3 of the double bond. Now I have to look at, is there cis-trans isomerism? Now, if you have two of the same group or atom on the same carbon double bond, you can't have cis or trans, which is why when I did 1-butene, you can't have cis or trans. But here, notice I have a plane here, and below the plane on each carbon is a hydrogen. And as it says here, oh, someone was nice enough to write on there, cis, same side, trans, opposite. So the hydrogens are on the same side, both below. So that's cis. So we now have cis 3-octene. Now in carbon 6, it's your old friend, the methyl group. And let me just do something. I don't know why my hand went to a lower font. Now it's back to normal font. And we have a methyl group. And it's on carbon 6. So that's 6-methyl cis 3-octene. Let's go through again. Find what's different. A double bond. How many carbons are in the longest chain of that double bond? And you count both carbons of the double bond. 1, 2, even though you show bond angle here, it's this carbon 2 is still connected to carbon 3 to 4. Even though I show bond angle going up, 4 is connected to bonded or linked to 5, 6, 7, 8. Octane. It's a double bond, drop the ANE ending, put ENE. 3-octene. And then if they're two different, in my case, my class will always be hydrogens, hint. And for most cases, it's true in organic chemistry, not all, but a lot. A hydrogen on both carbons, and they're below that dotted line or plane that's orthogonal. That means at a right angle to the double bonds. And that means cis. When they're opposite, that's trans. And then, so that's cis 3-octene. And then on carbon 6 is our methyl group. Now, the following you do not have to write down. Remember, cis is same side, trans is opposite. Everybody know what that is? You don't have to write it down. Everybody know what that is? It's transparent. Here and trans. With that bad joke, if I look at the clock, I said I was going to end early. Actually, we're going longer than I normally do on a Wednesday. I'm going to stop and say, listen carefully. Monday, I will go through the alkanes problem set. If you want to do good in my class and learn organic chemistry, do the problem set before I do. Keep up. Remember, Dr. White's very selfish. He likes things to happen around himself, around me that make me feel good. And it makes me feel really good, much better to see students succeed and get high grades than them not succeed. It actually makes me sad. So do the problem set. learn the alkane chart, learn the alkyl group chart. Also learn that first general reaction combustion. The other thing tonight, I'll have my office hour from about 6, assuming I don't have to spend too much time on my driveway. I've got a good sized driveway. It usually takes me in this kind of weather about 40 minutes to snow blow it. It's a good size one. And plus my sidewalks. But I'll have from 6 to 7:15 my office hour, because I'm going to do my driveway now instead of getting the video ready. It's going to be either later this evening or early this morning. Tomorrow morning, I'll post it. And with that, we're done. You survived the whole week of organic chemistry. Yay. Hopefully it wasn't that painful. And with that, I'll say gehen gesund, which is Yiddish meaning go in health. And I'll say bye now. I'll see you Monday, or if you come to my office hour, stole that from Granny of the Beverly Hillbillies. Bye.